So, if you've ever set up a basic AWS Direct Connect, you know it's a powerful private link to the cloud. But what happens when your business really starts to grow, when it goes global? That's what we're going to dig into today, moving past that simple setup to build something that's truly enterprise grade. Picture this. Your company is crushing it. You're deploying services in new regions all over the world, maybe Europe, maybe Asia. Suddenly, that single direct connect you set up last year, well, it starts to feel less like a superhighway and more like a single point of failure. Is your network actually built for this kind of scale, or is it one accidental cable cut away from a major outage? To get this right, we're going to master three core ideas. And these aren't just, items on an agenda. These are the actual blueprints for building a network that can span the entire globe, that can withstand failures, and most importantly, puts you in complete control of how your data gets where it's going. First up, let's talk about that global scale problem. The key, the secret sauce to solving this efficiently, is a service called the Direct Connect Gateway. You'll hear it called DXGW for short. The best way to think about this, it's your universal connection hub for the entire planet. So what is it exactly? Well, a Direct Connect Gateway is a global thing. It doesn't live in just one region. Its entire job is to be a central point that lets you link your on-premise network to all of your VPCs in any AWS region without having to manage a whole mess of individual connections. Before the DXGW existed, trying to scale was a total nightmare. I mean, it meant you had to get a new, really expensive Direct Connect port and set up a new private virtual interface, a VIF, for every single AWS region you wanted to expand into. It was costly, it was complicated, and it just didn't scale well at all. But with the Direct Connect Gateway, man, the whole picture just changes. Your on-prem network connects to the DXGW just once, and that one gateway then fans out to all of your VPCs, no matter where they are in the world. It's this beautifully clean, simple, and really powerful hub-and-spoke model. So the big takeaway here is, why do this? Well, you completely get rid of the need for dedicated ports in every single region. You can stop managing a separate VIF for every VPC you have. This just slashes your costs and complexity. And, as we're about to see, it is the perfect foundation for building a truly highly available network. All right, so that brings us to our second pillar, architecting for high availability. I mean, a global network is great, but it's not very useful if one little fiber cut can bring the whole thing crashing down, right? We have to get rid of those single points of failure. Now, AWS is pretty clear that you should have at least 2 direct connects. And there are basically 3 main ways to set this up. You can think of it like a good, better, and best approach, all depending on what your business really needs. There's a standard model that works for pretty much everyone, a mission-critical design for absolute maximum uptime, and a more cost-effective hybrid option. What's great here is how you can map the architecture directly to your business needs. For most companies, having 2 direct connects coming from different physical locations but terminating on a single DXGW, that's the sweet spot. BGP just handles the failover automatically. But if you're in an industry like finance with some crazy high SLAs, then a dual DXGW setup gives you 2 completely separate network paths. And hey, if budget is the main concern, using a site-to-site VPN as a backup is a really popular and effective strategy for disaster recovery. Okay, so we've got scale, we've got redundancy. Now for the final piece of the puzzle, control. How do we actually tell our network traffic which path it should take? This is where we get to use the power of the Border Gateway Protocol, or BGP. BGP gives us 2 main levers we can pull. Think of it like giving directions to a delivery driver. To control traffic leaving AWS and coming to your data center, we use something called local preference. You set this on your own routers, and the rule is super simple. The higher number wins. Now, to control traffic entering AWS from your network, we use what's called AS path prepending. The AS path is just the list of networks a route has traveled through. By making that list longer, we make the path less attractive, because BGP always prefers the shorter path. Let's make this real with an example for outbound traffic. Let's say you want Direct Connect 1 to be your main primary path. Easy. On your on-prem router, you just set a higher local preference value for the routes you learn over DX1, say 200, and a lower value for the routes from DX2, like 100. That's it. All traffic leaving AWS will now prefer to go through DX1. Now, for inbound traffic, we just flip the logic.
If we want DX2 to be our backup path, we use that AS_path perpending trick. Think of it like adding a bunch of extra pointless stops to that delivery driver's route. By adding our own network number a few times in the AWS console for that DX2 connection, we make the path look artificially longer. BGP sees this longer route and naturally says, nope, I'm taking the shorter, more direct path over DX1.
All right, we've covered the 3 big pillars: global scale with the DXGW, high availability with dual connections, and precise traffic control using BGP. Now for the payoff. Let's see how all these pieces snap together into one complete enterprise blueprint. And there it is, the whole shebang. Let's walk through it. We start with our on-prem routers, where we set local preference to control our outbound traffic. Those routers connect over 2 physically separate direct connects for redundancy. Now, both of those connections terminate on our single global direct connect gateway. That's what gives us scalable access to all of our VPCs, no matter what region they're in. And finally, we use AS_path prepending in AWS to influence the inbound path. Scale, redundancy, control. It's all working together perfectly. So what are the key things to walk away with? First, use a direct connect gateway. It's the key to simple global scale. Second, always use at least 2 direct connects from different locations for real high availability. And third, use those BGP tools, local preference and AS_path prepending, to take total control of your traffic flow. You put those 3 things together, and you have built yourself a truly resilient enterprise-grade hybrid network. So now you have the blueprint for a powerful global hybrid network. But what's really cool is that this foundation opens the door to even more advanced designs. The next question you should be asking is, what happens when I combine this amazing architecture with the power of Transit Gateway? Because that is when you unlock the ultimate enterprise networking solution.